For 80 years, experts argued America's first settlers crossed a land corridor unlocked by melting glaciers. But newly discovered underwater evidence off California's coast, settlements at depths matching sea levels 13,000 years ago, proves humans arrived there before any ice corridor existed. If the traditional story no longer fits the data, what did these submerged sites reveal? And why has this truth been hidden on the ocean floor? The mainstream account held that the first Americans entered through a corridor between massive glaciers, a narrow passage that only became passable around 12,800 years ago. Yet, radiocarbon dates from California's Channel Islands told a different story. Human occupation on Santa Rosa and San Miguel stretches back more than 13,000 years, hundreds of years before the inland corridor thawed. These findings weren't isolated. Chert crescents, stemmed projectile points, and dense middens of shellfish and marine mammal bones surfaced from carefully excavated island sites, all pointing to a population thriving along a coastline rich in kelp forest and ocean resources. The contradiction was stark. If the ice corridor was sealed by impassable glaciers, how could people have reached islands separated by miles of open water? The tools recovered bore little resemblance to the fluted points of the Clovis tradition found inland. Instead, they matched the needs of seafarers, thin, barbed, and designed for hunting in and around water. The chronology was unyielding. 13,000-year-old settlements on islands that, at the time, formed a single landmass, Santa Rosa, lying far beyond the reach of any overland traveler blocked by ice. For decades, each new discovery fueled a debate that divided archaeologists into two camps. Proponents of the inland corridor pointed to sites like Paisley Caves in Oregon, with coprolites dated to roughly 14,200 years ago, arguing that early migrants could have adopted coastal lifeways after arrival. Coastal advocates countered with the physical impossibility of reaching the Channel Islands by land before the corridor opened, emphasizing the specialized tools and subsistence patterns found exclusively along the Pacific margin. The evidence from California's islands, radiocarbon dated and stratigraphically secure, set the timeline in stone. Human presence here predates the inland route's viability. As the standoff deepened, attention turned to the geography itself. With sea levels 400 feet lower than today, California's coastline once stretched more than 6 miles farther west, exposing vast plains and river valleys now lost beneath the Pacific. The land that connected Santa Rosa to the mainland, and any trace of the first coastal travelers, had vanished under rising seas. The answer to the migration mystery, it seemed, was hidden somewhere offshore, waiting in the darkness beyond the modern shoreline. At the end of the last ice age, the California coast looked nothing like it does today, where cliffs now drop into pounding surf. A broad plain once stretched more than 6 miles west of the modern shoreline. This lost landscape, exposed when sea levels stood 400 feet lower, connected the Channel Islands into a single landmass, Santa Rosa, and extended the continent deep into what is now the Pacific. The evidence for the earliest Americans, if they followed the coast, would lie somewhere along this vanished edge. Geologists reconstruct this ancient shoreline by charting the global rise in sea level after the last glacial maximum. Roberts' sea level curve, built from hundreds of core samples and radiocarbon dates, shows a steady climb, sometimes 2 or 3 meters per century, as melting ice sheets poured water into the world's oceans. By 13,100 years ago, the sea had advanced enough to drown the paleo shoreline off Santa Rosa Island, submerging the plains and river valleys where people once lived. Today, that ancient coast sits 65 meters beneath the waves, buried under layers of silt and sand. Bathymetric mapping and high-resolution sonar have traced this drowned shelf, revealing terraces and channels that once marked river mouths, freshwater springs, and rocky outcrops, prime locations for early settlement. These features do not just mark where the shoreline was, they define the precise hunting grounds for underwater archaeologists. The challenge is immense. The continental shelf off California is vast, and only a fraction has been surveyed with the detail needed to spot subtle traces of human activity. But the logic is inescapable. If the first Americans traveled by sea, their campsites, middens, and tool scatters now lie hidden along this paleo shoreline, preserved by the very waters that erased them from view. Modern technology has shifted the search from educated guesswork to targeted investigation. Geographic Information Systems, or GIS, integrate sea level curves, bathymetric data, and predictive models of ancient resource zones to pinpoint the likeliest places for human occupation. By layering these data, researchers can narrow the search to high probability grids, drowned terraces, ancient river mouths, and chert outcrops, where the next breakthrough may wait. The submerged shelf off California is not just a blank expanse, it is a map of opportunity, shaped by the tides of deep time and the migrations of the first coastal peoples. At 65 meters below the surface, the ancient coastline off Santa Rosa Island holds little to the naked eye, just shadowed outcrops and silted terraces. But this is where the search began in earnest. Marine geophysicists charted the seafloor with high-resolution sonar, each pass revealing subtle terraces and alcoves that once overlooked open plains. The real breakthrough came when Dr. Liu overlaid the bathymetric data onto a GIS heat map. One zone lit up with a 0.87 probability score, a statistical outlier in a grid of low numbers. Divers prepared for a targeted descent, equipped with rebreathers and digital mapping gear to navigate the low visibility and unpredictable currents. The first limestone alcove yielded more than expected. Nestled in a protected pocket, a scatter of stone crescents and bifaces was visible beneath a thin layer of sediment. It was documented in place using photogrammetry and 3D scanning, preserving precise spatial relationships for later analysis. The process was painstaking. Divers worked in short shifts, logging each find and extracting sediment cores for laboratory study. Back on the surface, the recovered assemblage underwent initial classification. The stone tools showed distinct wear patterns, edge polish from cutting kelp, microfractures from working bone. On a drowned shelf, mapped by modern technology and recovered by hand, the physical traces of California's earliest mariners had survived the rising sea. Charcoal fragments recovered from the upland springs of Santa Rosa Island were sent to the Accelerator Mass Spectrometry Lab for radiocarbon analysis. The results were unambiguous: 13,200 plus or minus 150 calendar years before present. Calibration curves, adjusted for local marine reservoir effects, confirmed the age. These samples came from secure, stratified layers, ash lenses sealed beneath undisturbed sediments, intermixed with crescents, stemmed points, and the remains of marine birds and mammals. Laboratory protocols followed strict pre-treatment to eliminate contaminants, with the final ages modeled using OxCal and IntCal 20 calibration standards. At the same time, glacial geologists mapped the retreat of the Laurentide and Cordilleran ice sheets. The ice-free corridor, long considered the main entry to the continent, did not open until 12,800 years ago, based on sediment cores and cosmogenic nuclide dating from the Mackenzie Valley. The contradiction between these two timelines is absolute. Human occupation on Santa Rosa predates the inland corridor's existence by 4 centuries. The Channel Islands were isolated by open water, their paleo shorelines already drowned by the time the corridor became passable. The context was as strong as any in North American archaeology. Michael Waters, whose own work at Monte Verde helped overturn the Clovis first model, described the California chronology as the chronological anchor for the Pacific migration. The Channel Islands' 13,200-year-old occupation, locked in by AMS dates and glacial models, leaves no room for the corridor first hypothesis. The sequence is now clear. The Pacific coast was settled before the inland ice gave way. Today, sonar and science expose a story the land can't tell. California's submerged coast rewrites our origins in real time. As new discoveries surface, every tide reminds us that the answers to history's biggest questions still lie hidden beneath our feet. What will we find next?